Well, hello guys, Mr. G here with another video. This time we're going to be solving a question paper related to electrostatics. As you can see here, electrostatics is an important topic. It's going to be in the grade 12 examination. This one is mostly for the grade 11, but obvious the grade 12 need electrostatic as soon as they need it yesterday, let's say. Before we continue, before we start, please don't forget to subscribe for the channel so you can get the notifications, and I post videos on a regular basis. Without saying more, we're going to start, and obvious, the first question we're going to answer is always going to be the multiple choices. The question 1.1 say point charge M has charge Q and point charge N has charge 2Q. They are separated by a small distance R. Which one of the statement below about the electrostatic force that the F M on N, which M exert on N, and the electrostatic force Nm, which N exert on N, is correct? Now, independent of the charges here, the forces are going to be the same, guys. That one is Newton's third law. There is a charge and a point charge M that is here. It doesn't matter the size of the charges, and this one is N. The forces are going to be the same but in opposite direction, and therefore the correct answer is C. Without saying more, this one is quite simple, guys. Just need to remember that they have, Newton's third law said that if object A exert a force on object B, then object B exert a force on object A, which equal magnitude but in the opposite direction, and that is the case of this question 1.1. Quite simple, you didn't have to do much. Question 1.2. Two small identical metal spheres on isolated stand carrying charge of minus Q and positive 3Q respectively, as you can see here in the picture. When the centers of the spheres are a distance d apart, the spheres exert an electrostatic force of magnitude F. And just to remember, that electrostatic force that we're speaking about can be F equal to K Q1 Q2 divided by the square of the distance. Okay, this is the electrostatic force we are talking about. In other words, this is Coulomb's law. When the center of the spheres are distant d apart, the spheres exert an electrostatic force of magnitude F on each other. This one is with this distance, which in this case is not R. They use the symbol d, so let's substitute this one by a d, but it's the same. That letter doesn't change anything. The spheres are now made to touch and are brought back the same position as before, which means the distance will stay constant. The magnitude of the electrostatic force which the spheres now exert on each other in terms of F is. Now, what is going to happen here? And this one is a very interesting equation. Now, the spheres are going to touch each other and they're going to be separated. So during the touching, guys, what is going to happen? The electrons are going to be transferred from one sphere to the other. And then they will have a new charge after they touch. So we have to add Q1 plus Q2 and divide by 2. Remember, this is the conservation of charge. So this is the first thing you have to do here. Now you have, which is minus 1 plus 3 divided by 2. And when you solve this one, you get that each of them, each of the two spheres will have a new charge of 1 Coulomb. All right? Or whatever is the case. They're not asking about Coulomb, but they're going to have a charge of 1 K. So let's substitute Coulomb and write K here. So now we're going to substitute in the formula of Coulomb's law that we have. So we're going to come here and we say that F new, because it's the new force with the new charge, is going to be equal to K. Now, what happened to Q1? Q1 stay with the same magnitude of 1, because remember, each of 1 will have a magnitude of 1 Q. So it's going to be still, I'm going to write Q, and in this formula you do not substitute any signs or things like that. Now the second charge was 3Q, but now it's going to be also 1Q, so it decreases by 1/3. So it's 1/3 of Q. divided everything by the distance square, and the distance stay constant here. Now when you solve this one, now this one is simple math. This is 1/3 of k q1 q2 divided by the distance square. This one here on this side is the same as the initial force we're starting with. So what it actually happened to the magnitude of the electrostatic force in this case, it decreases by 1/3, and therefore the correct answer here is going to be A. This one is a very good, interesting question. I never saw it before. Now, question 1.3. The center of two identical metallic spheres, each carrying a charge Q, are a distance r apart. Which one of the following pairs of charges they are made simultaneously will double the... This is a very important statement here. They are made simultaneously. So together, when they come together, the two sizes on left and right, they will double the electrostatic force. When they come together, the electrostatic force is going to be double. And guys, the way of working here is very, very similar, and it's a very good question which we are going to do right in a new page. Now remember, here in this question we are looking for the one that the force or will lead to a force which is double to the first one. Now guys, we are going to be doing the same. So we're going to start with A here, and we're going to say the initial force is equal to K charge 1 charge 2 divided by distance square. And this one is going to be the new one, not this one, but the new one, they change. So for the new one, under this specific condition, no net, let's write new rather than net, new is going to be equal to K. That one stay constant. But now they say here that the charge double the charge in both spheres. So we'll have 2 Q1 and 2 Q2. Do you understand this one? I hope you understand. 2 Q1 and 2 Q2, because each of them is double. And now the distance is going to be half, as you can see it on this side there. The distance is half. So R divided by 2, everything to the power 2. Now when you solve this one, we'll get here that is 4, because 2 times 2 is 4, K Q1 Q2 divided by, and when you solve this one, is R squared divided by 4. There we go. Now this one, guys, you divide by the inverse of the denominator here. So you get that F nu, remember we're looking for F nu here, you have that this one is going to be equal to 4 K Q1 Q2 divided by 1 times 4 divided by R squared. You multiply to take off this division here. This is maths. To take this division, you multiply by the inverse. Okay? So in this case, when you solve this one, you will get that the new force is going to be equal to 4 times 4 is 16 K Q1 Q2 divided by distance square. And if we rearrange this one, and let's say no rearrange, but we organize and take the 16 out, if we change these things here, like we read the question now, the new force is going to be 16 times bigger than the initial force, and the question is double. So A is not an answer. Now you are going to keep doing the same procedure for each of them. So let's go and try to do it for B. So for B, we're starting with the force K Q1 Q2 divided by distance square, and we are going to change for the new force. We are going to make the changes they are telling you there on top. So for B, they say that the distance decreased by half, but they reduce the charge on one sphere to half. So in this case, you have Q1 divided by 2 because it's half, or let's not do this. Let's say half Q1. Q2 stays the same and the distance is half like before. 4. So half the distance, everything square. And now guys, you have to solve this one here. So what we have there is that this one is half. Let's isolate that one. K Q1 Q2 divided by R square divided by 4. This one is what you have here. Now when you solve this one, what you're going to do is exactly the same as before. This one is going to be equal to half K Q1 Q2 times 4 divided by R square. And when you solve this one is simple maths. When you solve this one, you can see that this 2 and this 4 will simplify, and you will have here that the new force is going to be equal to 2K Q1 Q2 divided by distance square. Kaboom. This one is the force that we had before, which is this one there, and therefore the 2 in front, if you change, or for this scenario, the new force will be equal to 2 times the old force. Guys, this one is the answer. This one is the answer because the question asks for which one will give you a double force. So when we come back to the question, they say which one of the following pair of charges will double the electrostatic force? It is B. Now, my humble recommendation is try to do it for C and D alone. It's mathematics, and there is always going to be such a question in the test. Not exactly the same like this one, but it's the same approach. Let's go to the last one of the multiple choice here. The electrostatic field pattern between two charges Q1 and Q2 is shown below. Now, you have to remember that the electric field lines always start at the positive. So Q1 must be a positive charge. There's nothing to say there. And Q2 must be a negative charge. There is nothing to say, because by convention the electric field pattern between two charges is always going out in the positive and in the negative. So which one of the following statement regarding the charge Q1 and Q2 is correct? Well, Q1 must be positive, so for Q1 is either going to be this one or that one, but we know that Q2 is negative, and therefore is this one. The correct answer is D. And this is the end of the first question 1, which is a multiple choice. Multiple choice attempt to be complicated, so they are not so easy as they look. Now question 2, now a little bit longer question. This question said 3-point charges QA, QB, and QC are placed in the vacuum as shown in the sketch below. The distance between point charge QA and QC is 20 centimeters, and we are going to change those. This 20 centimeters is equal to 0.2 meters. Remember, you cannot work in centimeters, while that between QB and QC is 5 centimeters. So this one is 5 centimeters, or is the same as saying 0.05 meters. This is data, and a data is a very important step to solve any question. Question 2.1, state Coulomb's law in words, and we are going to look for Coulomb's law in words. But before we do that, let's go to the formulas. Here we are, and guys, this formula here is Coulomb law. This is Coulomb's law, but you must be able to say it in words. So here in words, you say that the force of the electrostatic force, first you have to say that the electrostatic force is directly proportional to the product of the charge. That is the first important part of the law. Remember, you have to speak about charges. Be careful, because if you by accident mention the word mass, you may lose all the marks. And the second part, as you can see it here in the formula, is inversely proportional to the square of the distance between them. That is Coulomb's law, and if you look here and you learn how to read this formula, it can help you to remember. So this one here is question 2.1. I am going to leave it right there. You can come back and watch the video on this part. So this part of the question is done and dusted. Question 2.2. How does the magnitude of the electrostatic force exerted by point charge QA on point charge QB compare with the magnitude of the electrostatic force exerted by point charge QB on point charge QA? We are talking about magnitude, so no direction needed. If we go back to the very first question of this test, here is a similar one, but they ask for the force in all terms. So the magnitude will be equal to, this is the correct answer for that specific question there. And that, guys, is the answer for question 2.2. Now, question 2.3, it could be the difficult one here. Determine the nature. Now, when they say determine the nature, they means it's either positive or negative, and calculate the number of protons or electrons in charge QC so that the net electrostatic force on QB is 0. This may be a tricky question. Remember, first of all, to calculate the number of electrons, we need to use this formula. It's charge quantization done in grade 10. This one is the elementary charge, okay? Now, that is what we need to know. But to know that, when we're working on charge C, so here this is QC, so we don't forget that one. Now, let's go back quickly to the picture here, and we are going to work with it a little bit. Now, they're working with C, so that the net electrostatic force on B is 0. So on B, right here, at this point here, the net force is equal to 0. Now, this is vectors. This is Newton's first law. You've done it before, so you know what is happening. If net force is 0, it means that that point is at equilibrium. Point at equilibrium. In other words, remember that we mentioned this one before. The forces on the right must be equal to the forces on the left. Now, on the left, we have QA, which is positive, and QA is been attracting this charge of point B with F force here, which I am going to call FA on B. That is what we have. Now, remember, we're back here. Net force is 0 at that point. So to balance this force, or the equivalent to this force, must be another force that has the same magnitude to that one in the opposite direction. And that force must come from C, FC on B. Now, if C is pulling B towards itself, it means that B must be a positive charge, guys. I hope you really understand what I explained in here, because of the forces that is going to their right. In this case, is the force from C on B must be equal to the force that is going from A on B, which is to the left. And this is the thing that is going to help us to calculate the charge. So, how to start this one? First of all, I will start saying that the net force is equal to 0. Net force on B. That one is given to you. We're working on B. Now, on B, let's redraw here what is happening on B. We have one force pointing to the left, which is FA on B. There is not gravitational force because we are in the vacuum. And there is another force pointing to the right, which is FB on A. Now, for you to understand clear, you, as always, have to select a direction. So whatever direction you select, and let's say, for instance, this direction is going to be the positive direction, it means that this force is a positive force, but this one is a negative force. So if we substitute here in Newton's first law, we have that FB on A minus FA on B is equal, not B, pardon, is C. C on B. C on B here. I'm really sorry. This one is C on B. Show you in the picture on top. C on B. See there. There it is. Be careful with that one when you're moving from side to side. So this one here is C on B. Let's fix that one before we carry on. C on B and A on B, and all that is equal to 0. Therefore, if you rearrange this one, you get that force C on B is equal to force A on B. Guys, and the rest is substituting the Coulomb's law in here, where you say K is equal K multiplied by QC QB divided by the distance between C and B square is equal to K QA QB divided by the distance AB square. And then if you can see here, mathematically speaking, a K can simplify as well as QB because it's a common factor there. So what we having behind here? We have that QC divided by the distance CB square is equal to QA divided by the distance AB square. And the rest is to substitute, and we are going to do that real fast. Now here I want you to notice something. The distance here between between A and B, which is from here to here, guys, is only this distance here, and we don't have that one. So that one will be 20 centimeters minus 5, which is 15 centimeters. Be careful with that one because you are in a hurry and you may forget or confuse the number. So this one is 0.15 centimeters. You have to convert to meters square, and the rest is to calculate. So QC, the answer is going to be 5.55. I'm going to leave it there. 7 times 10 to the minus 7 coulombs. This is not the final answer. Remember, we have to calculate the number of electrons or protons. In this case it's proton because the charge is positive. So we are going back here and substitute to calculate this n. Charge C, it is calculated there, 5.557 divided by the charge of one electron. That I want to show you something. It is also going to be giving you that one. That is the charge of an electron. We're working with a proton now, but it's the same charge, just positive, guys. So when you substitute here, you will get that the answer is 3.473 times 10 to the 12 protons. You get protons there. And this, guys, is the question to this question there. I hope you understand. It's not that bad. So that is how to calculate the number of protons. While you understand this part here, you will be able to answer the question, but that is question 2. That is the whole question 2. Okay guys, so we're going to stop here with question 2. Next video, which is going to be tomorrow, we are going to be doing question 3 and question 4, and that will be the end of the video. Please don't forget to subscribe for the channel, thumb up if you like it, write comments. I'll see you next time. Mr. G here.